Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you. Welcome back team, and we'll continue learning the Linux basics again, right? So I think so far we have understood the Linux operating system basics to understand how to get started or how to use to with the Linux operating system terminal, because Linux is the command line based operating system, right? So anything that you wanted to interact with the Linux operating system, right? The corresponding set of commands are there. We need to run the commands to get it done, right? And we have learned certain few basic commands so far in the Linux, which will explains or helps us to work with the Linux file and directory hierarchical structure, where we can navigate the folders and create file and directories and remove them as well, right? And we talked about the absolute path and the relative path, right? And how do we use them when we are referencing the path of a file or a directory in our commands, right? And then we have understood that the in the Linux system, everything that we are going to deal with is definitely a process. Without a process, right? So nothing will be happen on the Linux system, right? It could be very small thing. Yes, definitely there is a process, right, which is created, and that process is responsible to execute your instruction, your input, your command, or whatever it is. Are we good with this, right? So any process will have the process ID, will have the parent process ID as well, right? And the process will have a process owner. The running processes, we can see it in the ps-ef command, right? The running processes will be stored in the real memory, and those processes will be get removed from the from the real memory once the processes are get completed or terminated. Correct? This is the general strategy that we talked about. And any command that you have executed, the command is basically a binary file that is located in the server itself in so and so location. Usually all the binary files, like the command files, will be located in the /usr location, right? So all those binary files are kept available as part of the OS installation only, right? In our case, we are not installing the operating system because this is the cloud platform. When we ask AWS, hey, I need this operating system, it's the AWS responsibility to ensure that the requested operating system is available on the EC2 instance, and they have given it to you. We can just go ahead and start using that operating system by logging in. I think that's the quick summary, right? What is that we have been done so far, right? So again, right, as I see a question in the chat window, right? Yes, if you go deeper and deeper, yes, I think in this particular, yeah, I think in this particular diagram, I have talked about the command instance or process is created, right? So if you go on deeper and deeper, each and every command or each and every process will be get divided it into multiple threads, right? And the processor will be executing on the threads, but we are not really worrying about the thread level concept, right? So at a high level, yes, the processes are created, the process will be taken care by your processor and it will be done. That's good enough, guys, right? If we are a kernel developer, right, so then we need to go in deeper and deeper in understanding what is thread and all, which is not really needed for our use case. Yeah. Well, team, so I think here you can see that there is one EC instance that is currently in running state. Let me quickly logging into this instance by using my putty, right? And I will just use this saved session. I will just log in there. I will be switching to the root, which is the super user account for me, and clear the screen, right? So that means what? Whatever the command that you run, the command is actually created as a process. Process ID will be created, and once you get an output, then that process and the ID, the process ID both will be get terminated. That will be removed from the real memory. That's what we have talked about, right? So in general, or usually, right? So whatever the commands that you are running in, maybe I'll just quickly run something like this. For example, I'll just go to slash, right? So usually whatever the commands that you run, these commands will be executed in a foreground. What does it mean by the foreground? Foreground in the sense the command will be executed on your terminal itself, and whatever the output that the command will produce, the output will be displayed on your screen itself. And then once this command is completed, then you will be getting a bash prompt symbol again, which will allow you to run any more commands, right? This is the general behavior which is called as a foreground process. So usually in the foreground process, right, once the command is completed, then only you will be getting the bash prompt symbol to run any more commands. But here is the question for you. So if your commands are getting completed within seconds, it is okay. I'll get the bash prompt symbol. I can run any more commands. But what is the case? Sometimes your command may take longer time, correct? Let's say your command will take at least 10 minutes to complete. Till that the command gets completed, you will not be getting the bash prompt symbol, right? Correct? So I don't have a command at this time to show you which will be taking a 10 minutes or half an hour, right? But at least for demonstration, let me run a command called sleep. This is just for demonstration, guys. Don't worry about what is the sleep command is doing, right? So basically the sleep command will just wait for this many number of seconds, nothing much. This is not doing any job for you. This just wait for this many seconds. After this many number of seconds, your command will be completed. That's what is the job is all about. I'm just running this to demonstrate you or to understand what is the foreground process. Okay. So if you run this command, you see now, did I get any bash prompt symbol to run any more commands, guys? All right. Why I did not got the bash prompt? This is kind of the hanging mode because the the command that I executed is not yet completed. So until the command gets completed, you will not be getting a bash prompt symbol. It will be like this only. This type of the behavior is called as a foreground process. So if your command is running in the foreground process, foreground behavior, which is the default nature, right? If you don't want this command to be completed, you can always run Control C. Control C is to terminate the process manually if you don't want it to be running for a longer time. And you see now, once you terminate the foreground process manually, now you back to your bash prompt symbol, or else we need to wait until the command gets completed, right? The other thing is whenever you are running the command in the foreground process, while the command is in running state, for any reason, if your session got closed or the internet is disconnected or something is happened, then your command will be interrupted. Let's say you have executed a command, the command take 10 minutes to complete. After 5 minutes, for any reason, your network got disconnected, right? The server is actually running in US East 1 region, right? and you are controlling that behavior from here. If the internet is disconnected, if your party got closed for any reason, then your command also will be interrupted, guys. That's the general behavior of the foreground. Being said that, do you prefer running a command in the foreground if your command is taking longer times? Let's say my command takes 5 minutes, 10 minutes, 30 minutes for some reason. So do you prefer running them in the foreground? No. Why? If that is taking 30 minutes, until the command gets completed, you will not get a bash prompt symbol to run another command. Also, for any reason, if the session got disconnected due to the network issue, and again the command will be get interrupted, right? So it's not a good practice. So in that situation, right, we can run the commands, especially the commands which are taking long time, right? And especially the commands which you don't want it to be get interrupted, even the session get closed, even the network is disconnected, still my command should running continuously in the background, because the server is in somewhere, right? If your partition get closed, it should not be impacted, right? The command can be continuously running in the background in the server which is located in the US East 1 region, right? So if you want to, if you want your command to be running continuously in the background, right? So we need to do this. We need to do the no hub. No hub is the command that you need to add before the command. The no hop in the sense no hang up. That means though your network is disconnected, though your party got closed, still your command should continuously running. That is what is the no hub, right? And at end you need to add the ampersand symbol and then hit enter. Now you see the command is executed, but this time the command is executed as a background process, and hence this is running in the background. You are able to get a bash prompt symbol to run any more commands. Is not mean that the command is completed, guys. No, this command is not completed. It is still running, but this is running in the background, right? So usually if the commands are running in the background, if the commands are showing any output, right? If it is foreground process, if the command is giving any output, you will be getting the output in the screen itself. If the command is running in the background, if that is giving any output, where the output should display, correct? So usually the output will be stored into a file called nohub.out. So one file will be generated like this. If any output is generated by this command, that output will come to this file by default. That's the default nature. In this scenario, I don't see any output here because my command is not producing any output. But if in case the commands are giving any output, right, the output can be seen in this particular file, right? Now, this particular command is running in the background, right? You should be able to see that command, right? You see in the ps-ef command, I can see that the command is running in the background with the specific PID and the process owner who have executed this command, all this information. If you don't want this background process to be running on the server, right, you can always go to this process ID and kill the process ID. You see now this particular command is got terminated, and you will not be seeing that command in the ps-ef as well, because I have manually terminated the background process that was scheduled to run in the system. Let me close the screen now. Sorry, clear the screen. So can I use this statement at this time, guys? Right? The ps-ef is the command which will be showing the processes which are currently running in the system, correct? The processes which are already completed, you will not be seeing them in the ps-ef output, correct? Being said that, I'm looking into the chart window, guys, and yeah, the comment from the Victor. Am I really going fast? I don't think so, right? If we are not spending like this much of time for this particular, again, guys, whatever you are talking about here, like the Linux basics, right? We don't need these basics to be a stronger and stronger, right? To work as a DevOps engineer, but we need a knowledge of these concepts to work as a DevOps engineer. So the overall the goal is all these concepts that I'm covering as a basics, right? We just need some understanding, right? But we need to spend lot of time on Kubernetes, AWS, Docker, right? Argo CD. So those are the advanced concepts that we need to spend a lot of time to be expertise in. So we are trying to balance the overall time that we have, right? Uh, yeah. So if you are spending a lot of time on the basic itself, we'll be getting less time for understanding the advanced concepts. And again, these concepts we just need some kind of understanding. We don't need a deeper knowledge here, guys, because we are not a Linux administrators at the end of the day. Right? Yeah. So I'll try to balance the things, but yeah, thanks for the acknowledgement on the chat window. I think I'm going in really very slow comparing to my general delivery style that I have followed so far. Okay, well, so like you know, the ps-cf command will show usually the processes which are currently in running state only. If the processes are terminated already, you will not be seeing them. You may be having a question at this time now, then, right? Any command will definitely run for, let's say if I take a ls command, you see this command is completed within seconds, right? But is there any command that needs to be running for longer time? Why the command is running for longer time? Let's say in this output you see all these are the processes which are running for longer time, right? That's why it is even all this list whatever you see, right? These will be running all the time in the system. From the time you start the system till the system gets shut down, right? When I say shut down, if it is AWS server, you go to AWS and stop the server, right? That is called as a shutdown, correct? So the processes that you see here, right? All these are actually running on the system from the time the system gets started till the system gets shut down. Why? Because these processes are actually doing some major job. These processes are actually helping to run the operating system itself. Got me? Somehow your operating system should be running continuously, right? Then only I can logging in from here and I can start doing this all these things, right? What does it mean, right? Sometimes the processes will be exited immediately within a seconds by giving you the output. Sometimes there are some processes which will be running continuously on the system from the time the system gets started till the system gets shut down, correct? So the processes which are running continuously on the system, those processes are called as a services. Just a terminology change, nothing much, right? Whether the process is running a second time or the process is running for 10 hours or the process is running throughout the time when the system is in up and running, everything is process only. Just to differentiate from the behavior perspective of the process, right? The process that is running continuously on the system, we are calling that kind of the processes as Linux services. Are we good with this? If so, I need to understand one Linux service which is running continuously on the system and why that is running continuously on the system. Again, back to my note. If anything is running on the system, or if anything is happening on the system, definitely there is a process which is responsible to do that. We agree on that statement, right? Let's say, let's say, as of now, I'm taking the IP address of this system. Now I'm trying to logging into the server. Okay. When I'm trying to logging into the server, what does it mean by logging into the server, guys? Currently, I'm located in one region. Maybe consider that I am the client. I in the sense Putty, right? Putty is the client software and is located in one place. And I'm trying to send the connection request to the server, which is located in the US East 1 region. Correct? When the party is sending the connection request to this particular IP, there should be someone who will take this request and give the response back, correct? If I go back to this particular slide one more time, right? You see here is the client. In general, in the IT terminology perspective, right? Uh, the one who is initiating the connection is called as a client. The one who is receiving the connection and responding back to the connection request is called as a server. From the terminology perspective, can I say that the party software is called as a client and the EC2 instance is called as a server? Are we good with this terminology? Right? Why? The party is the one who is sending or initiating the login request to the server, so that the party is actually sending the request to the server saying that, hey, I want to log into you. Then the EC2 instance, which is running in the US East 1, is responsible to receive the request, validate the request, verify the request is good or not. Then it will be giving the response back to the party saying that, okay, you are good to use my system, my things. That's where you will be getting the bash prompt symbol and the screen opens. Then you start running the commands over there, correct? So in this story, right, the question that I have here is, whenever the client is sending the request to the server, if the server is actually responding back to you, definitely there will be a service that is running on the server side who is responsible to take up the request, validate the request, and responding it back to you. Agree with me? Because we already know that if anything is happening on the server, definitely there is a process running in, or else nothing, right? Even to listen to the request that is came from the party or that is came from the client, to give the response back to the client, even that is also happening just because there is a service that is currently running on the system side. If that service is not running, then the client request will be ignored. The client cannot be connected to the server at all. In this perspective, what is it mean by the service, guys? The service is the process only, but which is the process which is running continuously on the system from the time the system started till the system gets shut down. That kind of the processes are called as a services. Now let me show you the process which is responsible in doing this at this time. If I go back to my Linux system one more time and look into my ps-ef output, out of all these different processes that are running in the system, there is one process which is responsible in listening to the client request and giving the response back to the system per login. That process is called as SSHD. You see this here somewhere? Yeah, here is the one. So if you look into this particular entry, right, and especially this one, right? So SSHD is the service name. This service is again a kind of a script, and this script is located in USR SBIN directory location. These are all default standard locations where these services scripts will be located as part of the OS installation, right? So this is the this is the service which is responsible in responding to the client request and validating the request and giving the response back, guys. If this service is not running on the Linux system, then the clients cannot be logging into. As of now, this service is set to start automatically when the EC2 instance is started, and it is running continuously on the system till the shutdown time. This service is keep on listening for the client request. Whenever someone is trying to log in, this service is responsible to take it and give the things back. Are we good with this? So this SSHD, right, which is called as a secure socket host, right? That is the full form of SSH, right? This is a just a process like LS process, nothing much, but this is some significant importance because this is running continuously on the system. I'm calling it as a service. The Linux services that are running continuously in, right, those services can also called as a daemon. Daemon is another terminology that we use. Daemon, a service, both are referring to same. You can call as a daemon or you can call it as a service. Both are same, guys. Hence the reason most of the times the services, right, are ended with a D. D refers daemon. In this case, SSHD is the daemon which is running continuously on this system with some specific process ID, and this daemon is responsible for all the logins that are initiated. Now, so when these type of the daemons or Linux services are running, we can control these services, guys. Like, of course, these services running continuously, but sometimes we can control them. We can manage like when we can stop the services, when we can start the services. All these things can easily be controlled, right? So the services, right, can be controlled using the command called systemctl. System control is the command which will be help us to control the Linux services. The command will be like this: systemctl sshd stop. This is the command to stop the service. Sorry, systemctl stop sshd. This is the command to stop the service. You see now the SSHD service is now got stopped. Can I see this SSHD service in the ps-ef now? Let me see that. So I'm running the command, right? So if you look into that /usr/sbin/sshd -d, that entry is really not there, right? Whatever you see here, this is the different one, guys. The one I have highlighted some time back, right? That is not coming up here, right? So pretty much the SSHD service is currently stopped. Being said that, now tell me, guys, if a client want to logging into the server, do you think the clients can be logging in? I'm giving this IP address even in the chat window where you guys can try from your side from the party or whichever the tool that you have. I'm trying here as well, right? Let's say I'm trying to logging into this EC2 instance from my client software. Let me try. Now you got an error saying that the connection is refused. Why? I send a request to the server. In the server side, SSHD is the service that should be running to take care of this. But the service is currently stopped and it is not ready to handle the request, and your request is refused and you are not able to log in, guys. That's how the SSHD service is more important to be running fine in the server. Then only all these clients can connect it to the server. If I go back to my previous terminal one more time, you may be asking me that if the SSH is stopped, how come this particular terminal is working? Usually when you stop the SSHD service, this service will stop working for the new connections. Like after this, whoever is trying to connect, that will be get rejected because this is not available. But the existing session, whoever has already logged in, right, those will continuously be working. That's the behavior of SSH. Hence the reason my current terminal, this terminal is currently working fine because I logged in when it was running state. Now I stopped it. Only the new connections will not work, but the existing logins will continue to be working. Good with this? So that's the systemctl command, right? So we can run the status command to see the what is the status of SSHD. Of course, you can go to ps-ef as well to see whether it is running fine or not, but we have a special command as well here. This command will tell you what is the current status of this process, and currently you can see that it is in active state and it will not work. You can start the process as well, right, by running systemctl start SSHD. Now you can try logging in from your side as well, because I given the IP address. Now I'll try to log in. Now you see that it is accepting the login and it has started off asking you, hey, what is the username that you wanted to logging in? Why? Now the SSHD is actually started there. So that's how the SSHD is the service which is continuously running on the system. It has to be running in the system continuously, then only the clients can connect it to the system, or else no. And these services can be manageable using the command called systemctl. Can stop it, can start it, can see the status, can restart as well. Restart in the sense it will go down and it will be started again. Good, right? Let's say currently I am in this terminal and for some reason I have stopped the SSHD and my terminal got closed unexpectedly. And what is the case now? How I can log in? The only solution is come back to AWS and you restart the system. When you restart the system, right, as part of the restart process, the SSHD service will be set to start automatically. I'll show you that command as well. So in general, or can I use this statement at this time? At least this SSHD process, which is important process, because if this SSHD process is running, then only the people can log in, or else no, right? So my requirement is this process should be started automatically when the EC2 instance is started, correct? When you go and launch the EC2 server, this service should be started automatically, right? Then only I can logging in first of all, correct? So we can control which services can be set to auto start during the system start time by running the command called systemctl enable SSHD. What this command is doing? This command will tell to the system that, hey, this particular service should be started automatically when the system is started or restarted. Got me? So this is already set to auto start. So whenever you restart the system, it will be started automatically as part of the restart process. So it will be back to running state, guys. Are we good with this? If you don't want any services to be started automatically when the system is started, then we can even disable them as well. But we can take a decision which will be started automatically, which cannot be started automatically. But in this case, my SSSD must be started automatically, because if that is running, then only I can logging in first of all to run any more other commands as well. Make sense? This is answering the question that I see in the chat window as well. Now, let me come back to the screen again, guys. Right. So I have created one EC2 server on AWS Cloud on the specific region, right? And usually the server will be created in any one of the availability zone, right? So far, I have not selected the availability zone where I wanted to. We'll talk about that later, but for now, definitely it will be running in any one of the availability zone, which is selected by AWS by default, right? The client is trying to logging in, right? And as we know, the SSSD is the service which is responsible for all these things. Good, right? So the SSSD service is actually listening on port number 22. What is this port number 22, right? Your EC2 server is actually designed, or the EC2 server is responsible for giving multiple services, guys. The SSSD is one of the service, right? What is the purpose of SSSD service? Just to recall one more time, SSSD service is a process which is responsible for giving the login services. Can I use the statement? Login services. That means this service is responsible for giving you a login services where the people can logging into the servers. That's the service that it is offering. Like that, the EC2 server is not only giving you the login services, it is giving various other services as well. N number of different services that the server is offering for us. This is the very first service that we are introduced today, but there are different services also that the server is offering. So when the client is sending the request to the server to get some services, right? How would your server know that the client is sending the request for which service? If you look into this table, right, just to understand the concept, right? Not only a SHS service, there are various other services also there which are offered by these servers. The service name HTTP, HTTPS, named, FTP, DNS, and there are many, guys. Almost hundreds of different services that are available that are offered by the EC2 servers, your Linux servers. Got me? So when the client is sending the request, right, how would your server know that the client is looking for which service out of all these different services that are offered? That is where the port number will come into the picture. Port number is just a identification number, nothing much, right? So here the SSSD service is set up in a way that, hey SHS, you are responsible to listen or to take up the request, whichever the request coming with the number called 22. That means if the client is sending the request for to consume or to receive or to use which service out of this list, the service specific number has to be appended, the number has to be added by the client to the request itself. That means the client has to tell that, hey, my request should go to number 22, my request should go to number 80, my request should go to number 443. Like that, the client should tell that, hey, my request should go to this number. In the server side, already the services are there binded to the corresponding number, so that these services will look for the request. Okay, if the request is came with number 22, okay, this is mine, let me take it, let me handle. If the request is came with number 80, okay, that is mine, let me handle by HTTP. That's how it will be identified, guys. Make sense? Just to take a pause here and give you some non-technical example here, because this is a little important, because a lot of things are logical here, right? We can't get to see by going into the server. Usually I give this example, right? Whoever is having a confusion with the port number, right? You just take the bank. A bank is offering multiple services, and within the bank there are multiple cabins are there. Each cabin is having some numbering system, right? The cabin 1, cabin 2, cabin 3. The cabin 1 is offering the loan services, cabin 2 is offering the no the credit card services, cabin 3 for the cash services, something like this, right? And the bank is acting as a server, serving certain services on the different numbers that they have been binded. Now you are a client. When you are going to the server as a client, the client should understand that the server is offering the services on which numbers, correct? Which service is offered on which number, that should be known by the client. Then when you are going to the bank as a client, based on the service that you are trying to use, you will be walking into the corresponding cabin number, correct? If you are trying to utilize the loan services, okay, you go to the cabin number 1 and you ask for the help. If you go to the other number, you will not be, your request will not be fulfilled. Agree with me? Same thing is happening here as well. The EC2 server side, the services are there. Each service is already binded with such specific number. These numbers are the default numbers across the world, right? And the client should know which number the client should use while the client is sending the request, right? If the client need SSH services, send the request using 22. If the client need HTTP services, send the request to port number 80, so on, so on, so on, so on. Are we good with this? Maybe you have a question here, then, right? As of now, we know that as per this chart, okay, SSH service is actually binded on port number 22. Do you think the client is sending the request on port number 22? Yes, we are doing that. As a client, whenever you are sending the request from your party, if you observe here, right, in the party, already the selection is there. The connection type is SSH, and I'm telling that send the request with the number called 22. So the party client will ensure that it is sending the request to the server by adding this number 22 as well in the request somehow. When it go to the server will see that, okay, it came with the number 22, this is mine, let me handle. The SSH service will take this up and will be responding it back to you. Are we good with this? If you use a different number here, let's say 25, it will not work. Why? I send it to a number 25 with the number 25. The SSH service will look into this. Okay, it came with number 25. This is not mine. I'll not handle this. And it will be ignoring, and your request is not fulfilled. Connection timed out. No one there to handle my request because no one there to take up on number 25. So the port number is the logical identification of a service where the service will be binded on the specific thing, right? So if you really wanted to see that the service to port number binding, you can use the command called netstat-tupln. Yes, these commands we need to by heart somehow, right? But in general, netstat means network statistics, and these are the flags that we need to use. So this command will tell you that SSHD is the service which is currently running with the process ID 3561 is currently listening port number 22. That's how we need to understand this output, guys. From the server, I'm telling this. The SSHD is now set up, is now configured to listen on port number 22. So whichever the client request is coming with the number 22, the SSHD will look into that and it will be processed. That's how it is already configured on that particular number. These numbers are constant and across the world. 22 is for SSHD. Good with that. Now, can I use this statement? Being said that, since the SSHD service is already set up to listen on port number 22, all the clients, whoever want to send the request to SSHD, should send by sending it on number 22 only. Then, or else it will not work. Correct? Now, coming back to PuTTY one more time. But why are we not worrying about this number so far? Because in general, by default, the PuTTY is automatically giving you this number and with SHS. So I don't need to worry about changing it anymore. Even if the Mac users, whoever is using the command line to connect, right, the number 22 will be added up automatically. So you don't need to worry about giving them manually, guys. So internally, it is adding the number 22 for you and it is sending the request. It know that the 22 is the number it has to send. That's the reason we are not worrying about this number, but we need to understand the concept, how it works, which number that it is sending the request. Did it answer the question that I see in the chat window? Now, coming back to this slide one more time, right? Now let's say, right, the client is sending a request to the server on number 22, and the SSHD is the service which is responsible, which is running, will look into the request. Okay, it came with the number 22, it's mine. Now it will be giving the response. Tell me, guys, what is that this SSHD will do here? Can I do like this? SSHD will, the step number one, will look into the request. Okay, it came with the number 22, this is mine, let me handle. Step number two, the SSHD will be checking the key that we have attached, correct? You see here in the PuTTY, you are actually attaching one key, right? For login purpose. Whatever the key that you have attached, even that key will be sending to the server. PuTTY will take care of backend, right? Your client will take care of automatically sending that key to the server. So can I say like this? So that the SSHD service is responsible to validate the key, whether the key is correct or not, correct? If the provided key is correct, then only the SSHD will be responding back to you saying that, hey, you are good to use the server and login is granted. You will get a bash prompt symbol. If the key is not correct, SSHD will tell that, hey, you are using the wrong key and your security is not passed and you cannot logging in. It will be rejecting the login, correct? So then the question here is, how would the SSHD know that the provided key is good or not, right? The provided key is correct key or a wrong key. How the SSHD know that? That's the first question. Or how would SSHD know that on what basis it has to validate the key? Should it validate the key or not, first of all? So that means there are certain settings that we need to tell to SSHD that, hey, this is the behavior how we need to work on, correct? We need to set some instructions, right? You follow these instructions. Based on these instructions, you please validate my login request and allow the login, right? Where do you set that? Because this is all a software, right? Somehow we need to tell to SSHD software as well, hey, you please follow these rules and work accordingly, correct? Let me see that here. The SSHD service is actually using the settings which are located in the location called etc ssh. etc ssh is the directory where the SSHD service related configuration files are located. If I go to this particular directory and see the list of files, you can see a lot of. Of course, all these are installed at the time the SSHD was set up. I don't need to worry. But I'm trying to tell etc SSH is the location where the SSHD service related some settings are there. It will use these settings to understand how it has to work. From the Linux language perspective, the settings are called as configuration. In general, if it is Windows, we use the terminology called settings, right? Hey, go to settings and change it. In Linux, configuration. That means in the etc SSH location, there are certain configuration files. These configuration files are being used by the SSHD service to understand the behavior, how it has to work. Out of all these files that you see here, the important file is sssd underscore config. This is the file. So slash etc slash ssh slash sssd underscore config is the file. This file has all the configuration information which is telling to SSHD how it has to work. If I open the file using a VI editor, you can see that it has a lot of lines. I think this file has almost 133 lines. This is called as a configuration file. The SSD service will be reading this file to understand how it has to work. And in any configuration file, if the line is started with a hash, that line is called as a comment line. That line will be ignored. Your SSD service will be ignoring the lines that are starting with a hash. The lines which are not starting with the hash will be considered. The SSH will read these lines, will understand. So far so good, right? Now we don't need to worry about this file, what this file, how this file is constructed, what the meaning of each and every line. We don't need to. In general, understand that This is the file having some settings, some configuration, which will be telling to SSS how it has to work on. That is good enough for now. Let me come out. I'll come back to this again. But still there is a open question, right? To my SSSD, yes, I'm telling that, hey, if you wanted to know the settings, you go to this file. It has already the configuration. You read the configuration and you know how it has to work on. That is still be fine. But how it know that the provided key is good or not, correct? That is not covered, correct? How it know that the provided key is correct or not? That is not part of your configuration file, right? Whether this file is good or not. We'll talk about that now. So I have the client and the server where the client and servers are connecting each other. In our case, the client is the party, server is the EC2 server, correct? The client is initiating the login, the server is trying to establish the login. So to make the communication possible between the client and the server, we are using the EC2 key pair, correct? Remember guys, we created a key pair in the AWS, right? And I have attached a key pair to the EC2 server at the time of launching the EC2 server, correct? Usually, when you create a EC2 key pair in the AWS, right, that process will be creating the two files, right? I hope you are able to hear me. In the AWS, whenever you create a key pair, that is actually creating two files. One file is called as a private key, the key which is actually downloaded to your local machine. Remember, when you create a EC2 key pair in the AWS, one file will be downloaded, right? That file is called as a private key, and there will be one more file will be generated as part of this process. That key is called as a public key. The public key will not be downloaded. The public key will be saved within the AWS control in their side. They will not tell us where the key is saved, but that public key file will be saved in AWS level somewhere. Okay. Now the private key and the public key files, these are just a files. Okay. The private key and the public key files, both files together, we call it as a SSH key pair, because these two key files are used for establishing a secured connection between the client and the server. Whenever you launch a EC2 server, whenever you attach the key pair from the drop down, AWS will ensure that the public key is actually copied it into the server. Got me? Private key is already downloaded, which is with you guys, correct? The private key is already downloaded, is in your laptop. The public key file will be get copied it into the EC2 server as part of the EC2 creation process. AWS will do that. That means, can I say this statement now? The private key is there in your laptop. The public key is already there in your EC2 server, correct? Who is doing that? AWS will do that. AWS will be copying this public key, the corresponding public key of your private key, because these two are key pair. that public key will be get copied into the server. When the server is created by the AWS, the key is available in the server. Now, the private key file is used to encrypt the message. The public key file is used to decrypt the message. When these key files are generated together as a pair, these two keys files are understanding each other, how to work with them. This is just a combination. The message that is encrypted by this private key can only be decrypted by this public key, no one else. That's how the keys are actually set up or created, right? If then, whenever the client is trying to connect to the server side already public key is there. The client side, the private key is the one which we are attaching to the putty, correct? When you attach the key in a putty and when you are trying to log in, that private key will be sending to the server. Server side already public key is there and it will try to compare, checks, and finally, okay, the keys are matching. The message that you encrypted, I'm able to decrypt, look like we are a trusted pair, you are granted. That's how it works in the backend. Are we good with this? I'm not going in deeper and deeper here, how exactly it will go in things, but let me come back here. To which user that I will be logging in, guys, usually from putty, from your client? EC2 hyphen user, right? So we already know that every user will have a home directory. Home directory in the sense, the default landing directory once the user is logged in, that is called as a home directory, right? For EC2 hyphen user, the home directory is /home/EC2 hyphen user, correct? In the EC2 hyphen user home directory, there will be a directory called .ssh. You see the PWD, right? In the EC2 hyphen user, because that is the default user that AWS is suggested, there is a directory called .shs. In that directory, there will be a file called authorized_keys. In this file, the public key will be copied, guys. Sometime back I said that AWS is actually copying the public key to the EC2 server, right? Where it is copying, AWS is copying that public key in this particular file, and you see this is called as a public key. Where is private key? The private key is in our laptop, right? The key which was downloaded at the time of you created a key pair. You see, this is my things. This is the key that I downloaded at my local, right? If I open this key in a notepad, you see, this is the private key that was downloaded at my local system. Some random characters are there. We don't need to worry about that, right? The public key is here. So whenever I'm using the putty for login, right? Whenever I'm using the putty for login from my client, I will be attaching the private key here. The key will be sending to server. In the server, right, in the user's home directory, in the .ssh folder, authorized_keys file, the public key is there. So these two keys will be compared. It will try to encrypt and decrypt the messages. If that is working, yes, looks like this key is correct, and the SSSD will be granting the permission. Are we good with this highlighted high level statement? Now, all good. The AWS is already copied the key into this location, into this file. This is the default behavior, guys, right? By default, it will be copied into user's home directory under .shes folder onto this file. The file name is also constant, always. The only question that I have here now, when the client is sending this private key file, how would your SSHD service know that the public key is in which location? Got me? If my SSHD know that the key is in this location in this file, then it can go to this file and it will read the public key and it will try to decrypt the message, understand that all these things. But how would your SSHD know that the public key is in this file? Any guesses? I'm going to root because I don't have much access to do. Any guesses? Again, this is the file, right? Sometime back I said SSHD underscore config is a file which has all the settings, all the configuration. If you look into this SSHD underscore config file, definitely somewhere it is mentioned that the public keys are available in which location. Here is the file. You see this? In this configuration file, somewhere it is mentioned that, hey, if someone is logging in, definitely the public key can be found in authorized underscore keys file in the user's home directory under .shs. So the SSHD will read this line, okay, this is the location. Then it will go to that location, it will read the public key, it will try to decrypt a message and try to validate the provided key is good or not. Then that is giving the authentication success or failure message back to there. That is how this SSHD underscore config file will help the SSHD to know all this login behavioral aspect of it. Are we good? Now, in general, whenever you create a EC2 instance, EC2 hyphen user is the default username that you need to use for logging into. Additional ROOT is the super user that will be there by default in all the Linux system because that is the super user. Sometimes we may need to create our own username as well, right? We will not be using only these two usernames all the times, right? If you want to create your own username, the command is user add space. Let's say I'll create a username myself. This command will be creating a username on the system. You can set a password for this. Password, specify the username. There's a typo, right? There are 3 R's there for some reason. That's okay. Now we can give the password here. So this is how, guys, we can create our own username and we can set a password for the user as well. Now this user can logging into this instance. A question for you now. So now let's say I wanted to logging into this EC2 instance from the party. Now the question is, I wanted to logging into the server using this particular username, the one which I created some time back. If so, can I use the private key file for this login? No. The key that was downloaded, the key that I used to attach, that key will be working only for EC2-user, not for any other, right? So I'm not attaching any key. Maybe I'll just do one more time. See, I'm not using this saved session. I'll give the IP address. Sorry. I will give the IP address there. This is the username that I want to log in. I'll increase the font for you guys. I did not attach any key, guys. The key will not work this time. That is only for EC2-user. This is the username that I wanted to log in, and now you hit enter. So it is complaining that no supported authentication methods, right? My requirement here is I wanted to logging into the EC2 server using the custom defined username and with your password because I don't have a key, correct? And SSSD is not accepting this login. Why? Let me go back to the existing session one more time. So every time if the SSH is not accepting the login, definitely we need to check for this file, correct? Because this is the file which has some settings. This is the file which has some configuration details telling to SSH how it has to work on, correct? If I go to this file one more time, somewhere you can see here, password authentication is the parameter which this parameter currently saying that no. What does it mean? This line is telling to SSSD service that, hey SSSD, you accept the logins only if the client is attaching the key. If the client is not attaching the key, right, don't accept the logins. That's what it is. Password authentication is no. Don't accept any password based authentications. Only key should be there. But in our case, for this PRD user, we don't have a key, right? I'm planning to authenticate using the password. So if you want to change this behavior on this file, right, we need to change this to yes. I'm changing the configuration. This is where you need the VI editor skill, correct? You need to move the cursor to the right place, overwrite, modify the no to yes, go back to command mode, colon, save and quit. I modified the file. Whenever you modify the configuration, it is mandatory to restart the service. Then only the service will go and read the modified configuration and it will be starting, it will start working on the latest configuration. If you don't restart the service, the changes will not come into effective. Since I have added the configuration to accept the password based authentication, now let me try to logging in. I'll increase the font one more time. Right now you see it is now expecting a password to be supplied. Why? I made a change in the SSH configuration. Now it is not looking for a key. Okay, Let me give the password. Now I logged into the server with my own username. If I look into the PWD, currently I got landed into /home/ like PRD. So this is now become the home directory for this particular user. Every user has their own home directory. Most likely the home directories will be in home location. The directory name will be the same as the username. That's the default behavior. The user that I created here is also a ordinary user. You can see that the user has got only a dollar symbol here. This user does not have a full privilege to do anything. This is just a simple not normal user. Whenever you enable the password based authentication, it means that now the SSH will support both password as well as the key. Key based authentication is always there, right? The password should be enabled or not. That is something that we need to take a call, because the key based authentication is always a secured mechanism, so no restrictions there. Password based login is not a secured compared to the key. That's the reason by default this password authentication is set to no. If you want, you go and enable it, right? The key based are always there, always it will be working. So now password as well as the key both will be working. I'm not saying that the key based authentication is disabled. No, I didn't disable that. I just have enabled the password login, and the both will be available now to use. Key based is recommended, which is more secured because the encryption, decryption, all this different stuff. Password based authentication is not secured compared to that. But I wanted to show you this to understand what is this SSSD service, how it is working, how we can modify the configuration, right, as per our requirement, and whole this process. Sounds interesting. So overall, what we did it, of course, we spent a lot of time, but if you summarize all of these things, right, SSSD is the service which is available by default in the Linux systems, which is set to auto start. The SSSD services are started by default when the instance is launched. SSSD service is listening on port number 22, which is responsible in giving you the login services, right? So the SSSD service can be controlled using the systemctl command. If any client want to logging in, the client has to send the request on port number 22. Then only the request will be handled by the SSH. The SSH will be knowing the behavior how it has to work by reading the settings from the etc sshs sssd underscore config configuration file, where you can modify the file as well as per our requirements. That's just what we have discussed for this today. But I went through step by step to make this more clear. Right now, I think that's the story for today, guys. I don't want to jump on to uh, one more new gear today, right? How to give the super user privilege to the ordinary users. That is something we'll discuss in the next lecture. That's where we will be entering into Linux permissions concept. I think that's the only lost concept in the Linux. Then we'll be going back to AWS again, right? We'll talk about the permissions, all this in the next lecture. Any questions? Do let me know. Right? And looking into the question, yes, authorized underscore keys is the file which is having the public key. AWS will copy the public key to that file by default when you launch the server that has a public key. The private key that you have attached in a putty will be now compared with the public key that is there in the authorized underscore keys file. Then it will make sure that both keys are matching. Right? So answering to the question, right, when it comes to the real time, we will always be working as a root only. Always we will be working as root user only in the real time. We will never ever work as a EC2 user or your own username. No, because the EC2 user or our own usernames are ordinary users, right? These users does not have a full permissions. Let's say if I want to create a file in slash, I don't have access, right? We will never be working on these ordinary users in the real time. Always will be in a root account only. But we need to understand what is ordinary user, what is super user, because though you are working on super user always, you will not be logging into the super user directly. First you log in as an ordinary user, then you become the super user. That's the process. So you should understand these concepts. Are we good with that? Right? So I'll try to give you one a small assignment, right? So that assignment will help you to just do some practice to be familiar with these basics. I'll give the or I'll send the assignment details in the group sometime later today. Usually all the assignments you can find in the course tracker sheet. In the course tracker, you go to the assignments tab, and this is the tab where you can see the assignment information. Assignment is just for your practice purpose. Whether you're doing, whether you are not doing, usually we are not doing the validation, right? You do it and come back to us if any questions, right? And at least for this week, I don't see any questions that are posted in the question tracker, so I don't have anything to cover regarding these question things. Okay, right? Answering to the question there again, right? Here the public and private key is actually creating by the AWS. Private key is downloaded, public key is getting copied into the server, correct? So my answer is very specific to question that I see there. Okay, so usually if it is a on premises, right, we need to create our own keys, right? We can create our own keys by running the command called sss-keygen. So this is the command that we need to run. This command will be creating the public and the private key files for you. We'll get a public and the private key files. So this command will generate the both files, and we can use these files as well to do this process possible. Okay, but I'm answering this question as I see a question there, but I will be talking about this command in next lecture to generate our own keys and how to set up the keys by ourselves as well. Not like sometimes I don't want to use AWS keys. I want to create my own public key, my own private key. I want to make this possible, right? We can do that. I'll talk about this again in the next lecture. Hope you like the session and you got the insightful information. Now at least you got some more clarity how the login is working from your party at least, right? Thank you. If any questions, do let me know, right? So that's what it is. And what do you feel, Victor? You still see that the sessions are going fast? I don't think so. Well then, I don't see any questions for there. Thank you guys, and have a nice weekend, and we'll catch up again Monday 7 a.m. IST. Thank you.